Good morning. For this assignment, you will be applying similar right triangles. Now remember that for similar triangles, the angles are congruent, the sides are proportional, right? So they have the same scale factor. Also, you only need to show two angles are congruent for them to be similar, or in right triangle, one angle other than the right angle. So we're going to apply this. I'm going to work through these two problems. Both of them we're going to find some value. Here it's y, here it's db. But I'm going to go through the assignment first. So there's a few problems just saying whether or not we can determine they're similar. Recall that either all three sides have to be proportional, or two sides are proportional and their included angle is congruent, or two angles in the triangles, two of the angles are congruent. So that's those two. Then there's two of these problems where you have to find the value of the variable. Again, these triangles are similar. They show that by two of the sides being congruent. Then we have this problem about the Unisphere in Flushing Meadow Park in New York. Yeah, I've actually been there and it's very impressive. They have this big globe and it's very neat, and it's a very nice park out there. And you're going to use triangles to figure out, similar triangles to figure out the height of the Unisphere. All right. So so that's an application, a good application. Again, finding a height that would be difficult to find otherwise, such as a globe like this. And then there's some problems involving right triangles, what we worked on today with the right triangles. Again, figuring out how to set up your proportions so we can solve for the variable. Here is x, down here is m. Notice they give part of the hypotenuse here, but you're looking for the entire hypotenuse to solve this. All right. And to help with that, we will just solve these two. Again, you want to set up proportional, so corresponding sides should be corresponding. So first we have two triangles here. I notice this longer side is on top. So I'm going to make that a proportion. So I'm going to say y minus 3 divided by 32. Okay. And then the other part, it's going to be 8 over 24 is these two, 18, excuse me, over 24 is the same side of the triangle. Okay. Notice on top is the left triangle and then bottom is the right triangle. So make sure that the same, it's related that way as well. Okay. So we can just cross multiply to solve this. So the remember to use parentheses because you're going to have to distribute. So 18 times 32 on the right, and we have 24 times the quantity y minus 3 on the left. So if we distribute here, 24y minus 3 times 24 is 72. And we can multiply, yeah. You know what? It would actually be simpler. Oh, let's just multiply it out. Actually, no. So it'd be simpler to actually divide and simplify, because we can divide, first of all, divide this by 6. So we are left with 3 here. Divide this by 6 and we get 12. Divide this by 6 and we get 4. Then we can divide this by 4 and it just gets canceled out. This divided by 4 is 3. Then we can divide the other part of it by 4 and get 8. So it is easier to simplify before multiplying. So then we're left with y minus 3 equals 3 times 8, right? 3 times 8 is much simpler than 18 times 32. So y minus 3 equals 3 times 8 is 24. Then we add 3 to both sides. And we get 27 for our answer. Let me write that 7 a little better. There we go. Y equals 27. And if we check back up here, that means this side is 24 units across, and that makes sense, right? It's less than this one, and it's about the correct proportion. So just check. For example, if this value was more than 32, that wouldn't make sense because this side of the triangle is less than this side, all right? Okay, and then in this one, we have to use the right triangles, right? So again, we're finding the other part of the hypotenuse, so we're gonna apply these two smaller triangles, not the big triangle. So what I'm gonna do is first I'm gonna take the long side of each triangle. So here on the left triangle, ADC, the long leg is 16. And on this triangle, the CDB, right, CDB is 12 is the longer leg, right? Then here, the shorter leg for ADC is 12 as well, right? With these formulas, you should have the same value. Either it's a variable or value in these two locations or something like that, the same value twice like this. And then the shorter leg is the unknown. So I'm just gonna call it DB this time. You could use a variable, but I'm just gonna leave it like that. So again, we can cross multiply. We get 16 dB. And we could write 144, but I'm gonna do the same thing I did last time. I'm gonna leave it 12 times 12 and just simplify. So first we divide by 4. We get 4 here and 3 here. I guess we could do 4 and divide here, but that's simple enough. So 4 dB equals 36. Divide by 4, and we get dB equals 9. Then again, I go back up and check, and 9. If I look at my proportions, like, yeah, this is the shorter leg of the smaller triangle, so it makes sense that it's a less value, right? It's the least value. All right, very good. So that's how we apply proportions to similar triangles, whether they're a right triangle or not. And that's how we solve this. So again, please work through all the questions. Just try your best. Again, please attend tutoring, review your notes, and I'm always available to answer any of your questions. Tutoring is the best time, but of course you can just email me or put a message on Google Classroom if you have any questions. All right, have a very good rest of your day, and I will talk to you next time. Okay, bye.